everyone, we're going to find the values of P for which the series is convergent. I already did a video for this same problem where P equals 1. I'll attach it to this, but I don't want to spend the time on this. I'll just attach the video in case you want to see it. So I already did this one, and when P is 1, it was divergent. I will attach that video. So what we want to do is assume to check for this that P does not equal 1. All right, therefore, we're going to have that it's f of x equals 1 divided by x times ln of x to the power of P. And it's continuous and positive on 2 to infinity. Now we have to see if it's decreasing. So we take our derivative of x, and we will get negative P plus ln of x divided by x squared ln of x to the power of P plus 1. Again, I already did a video on, I went into more detail on this, but that's just taking the derivative. Now this is negative only if x is greater than e to the power of negative p. So that's a little trick you have to know. If you substitute in x with e to the power of negative p, then it will be negative. All right. So that means it's going to be eventually decreasing, and we can use the integral test. So using that, we're going to use the integral from 2 to infinity of 1 divided by x times ln of x to the power of p dx. All right, so that's going to use our integral test. I didn't put that up there, but anyway, it goes like this. The limit as t approaches infinity, and then we're going to, let's write this as ln of x. Let's just write this out. Ln of x to the power of 1 minus p divided by 1 minus p. And we have from 2 to t. All right. Now this is for p not equal to 1. So now let's go ahead and substitute in our evaluation here. And when you get that, you're going to get the limit as t approaches infinity. And we have ln of t to the power of 1 minus p divided by 1 minus p minus ln of 2 times the power of 1 minus p divided by 1 minus p. All right. This limit only exists if this is going to equal 0 here. So basically, if we have 1 divided by 1 minus p, and then we have minus 1 divided by 1 minus p, we want our 1 minus p to be less than 0 for it to have a limit. Therefore, solving for p, our p must be greater than 1. Therefore, the series converges for p is greater than 1. Again, I'll attach the video for where p was 1. Thank you. Have a nice day. Bye-bye. Hi, everyone. We're going to determine whether the series is convergent or divergent. We are going to write our series and set this equal to f of x equals 1 divided by x times ln of x. Now this is continuous and positive. To use the integral test, it has to be continuous and positive and decreasing For ours, it's from 2 to infinity. To see if it's decreasing, however, we need to see if, take our derivative of x. So we'll use the quotient rule. So this is going to be 1 times the derivative of the denominator. That's going to be 1, just write x times derivative of ln of x, which is 1 divided by x, plus, this is the product rule here, and then ln of x, derivative of x is 1, and then minus derivative of the numerator is just 0, so that's going to go away. And the denominator, you're going to have x squared ln of x squared. All right, so this simplifies to 1 plus negative 1 plus ln of x divided by x squared ln of x squared. Now this is negative. I'll put the negative there. For x greater than 2, because of this negative, we have a negative and a positive divided by a positive. That's going to make it negative. So we can use the integral test. And to do that, we're going to integrate from 2 to infinity, 1 divided by x, ln of x dx. So before we get started using the integral test, let's go ahead and use u substitution. So if we let u equal ln of x, then du equals 1 divided by x dx. So we're going to have basically the integral from 1 divided by u du. All right, so then we'll substitute back in the u, and your u is going to be ln of x. So just keep that in mind before we start. So let's use the integral test for improper integrals. We're going to have the form of from 2 to infinity, and then we're going to take the limit. So it's going to be 1 divided by x times ln of x dx equals the limit as t approaches infinity. And then we already integrated this. This was ln of u, but our u is ln of x. And then we're evaluating this from 2 to t. So we get the limit as t approaches infinity, and then substitute in your t. We're going to get ln times ln of t, and then substitute in your 2. This will be ln times ln of 2. This is a constant, and this goes to infinity. So we have basically infinity minus some constant. That means it's divergent. So our integral diverges. That means the series from n equals 2 to infinity of 1 divided by n times n, ln of n, also diverges. Thank you. Have a nice day. Bye-bye.